We're going on a trip. Favorite rocket ship. Here we go. All right. So how do you do these? Like, first of all, there's people going like this. Look, we didn't even talk about all the other four. Like, I can do the first two because they're on that damn chart over there. I may get the signs wrong, but I got the chart. Let's just talk about it for a second. What's tangent? Now, some of you would have gone home, done something crazy, I don't know, innovative, like looked at the book, and you would have saw tangent. What's tangent equal to? Sine over cosine. So tangent is sine over cosine. So the idea here is if we know sine and cosine, then theoretically we know tangent as well, as it's a ratio. What's cotangent?
Cosine over sine.
Good answer. Cotangent is cosine over sine. You could also say 1 over tangent, which is cosine over sine. What's secant? Secant is 1 over cosine. And cosecant is 1 over sine. So I'm going to admit this in public and for the world to hear, all 17 people who watch this video. I had these two twins on my basketball team. I never could tell them apart. So whenever I would think to call one of their names, I would just switch it to the other one and figure out I was supposed to be wrong anyway. I'd be like, hey, Ian. Oh, nope, I'm just kidding. William. Okay? These two, when I was a student, used to screw me up all the time because when I saw cosecant, I swear I had to be cosine. Because it just made sense in my world. Like, if it's cosecant, cosine. And as a student, I went like this. All right, I'm always wrong. So it's, whichever one I think it is, it's the opposite. Now I finally got it. You know, after 6 weeks of teaching, I can now finally remember that secant is 1 over cosine. So there's hope for all of you. But it does not go the way you think it would, because you think it should be cosecant and cosine and secant and sine, but it doesn't do that. All right. Now, going back and making that chart again, we got sine, we got cosine, we've got a lot of values, we got 0, pi over 2. Remembering that pi over 4 is in the middle. And then count. 2, 4. This is 3. This is 6. Okay. 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. Square roots are across the board. Divide by 2, 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 divide by 2. Some of you looked at that divide by check mark. That's 2. Okay. Which gives us a very pretty chart that looks like this. Sine, cosine, 0, 1/2, square root of 2 over 2, square root of 3 over 2, 1, 0, 1/2, square root of 2 over 2, square root of 3 over 2, and 1. This is 0, pi over 2, pi over 3, pi over 4, and pi over 6. Now, it's extremely important to remember that this is only the first quadrant. To apply it to the problems that we did, we got to know which quadrant we're in so that we can adjust the signs accordingly. So cosine is the x values, sine is the y values, and then from there we will adjust them. Now, you have two options here. You can either A, memorize these 5 sets, plus memorize 5 more sets for quadrant 2, memorize 5 more sets for quadrant 3, and memorize 5 more sets for quadrant 4, or you memorize one set and then go adjust the signs. It's your world. I'm just paying rent. Okay, I don't care what you do. Memorize 20 of them, memorize 5 of them. It doesn't make any difference to me. I just want you to know the damn numbers. Capiche? That's my mafia reference for the day. I know when he says capiche, somebody's about ready to die. Where is 5 pi over 6? Which quadrant would that be in? All right, what you guys don't see at home is everybody's holding up their fingers for 2. They're right. It is 2. People at home can't see you. It's 2. So this is quadrant 2. Now, what do we know about quadrant 2? X values are positive or negative? Or negative, depending on if positives and new negative. So in quadrant 2, the x values are negative. So for this answer, the x value's got to be... Well, what the hell are you doing? I'm being ambushed. If I die, his name is Martin.
I had them negative in my whatever.
Oh, you had negative.
Yeah, I'm dumbass.
He just called himself a really bad name. I will neither confirm nor deny. And he's changing all of his answers that he just lost $1,000 to.
Not even. We didn't actually bet yet.
Oh, yeah. You just going to wait for the rest of the answers and then make a decision? So, with this, if we know that we're in quadrant 2, the cosine, the x value's got to be negative, right? The y value is going to have to be positive. I'm the same. The y value has to be positive, yes? Now, with that in mind, tangent sine over cosine, so positive divided by negative is negative. Cotangent's cosine over sine, so that's negative. Secant is 1 over cosine, so that's negative. And then cosecant is 1 over sine, that's positive. Can we all agree on that?
Can you just add a little line?
That imaginary 1 needs to be back up there again?
No. Like,
Yeah, I understand.
look at it.
No, I don't want to look at it. No. Yeah, just come on back up and fix it again. This is his 3rd attempt.
Not even.
This is his 3rd attempt. All right. So 5 pi over 6 takes me here. That makes the reference angle pi over 6. And then it's a matter of just looking at the chart. Yes? Go to the chart. Sine pi over 6 is 1/2. Cosine pi over 6 is square root of 3 over 2. Now, I'm going to tell you that the tangent is square root of 3 over 3. You're going to look at that like I'm some kind of like Chris Angel math magician going, whoa, how in the hell did you do that? Look, it's sine over cosine, right? So we have, in essence, 1/2 divided by square root of 3 over 2. The 2's will cancel, and you get 1 over the square root of 3. If you rationalize that, you'll get square root of 3 over 3. Okay? And that really, in full disclosure and in complete honesty, that's probably one of the hardest parts of this class, is how quickly I fly through all the fractions. And I reduce them and divide them and everything else, and I do it, relatively quickly. And then students are always sitting there going, whoa, where do those numbers come from? If you ever don't know, it's okay to ask. Okay? I've been doing it for a long time. Okay? Cotangent. Cosine over sine, that's going to be square root of 3. Secant. That's 1 over cosine. So that's 2 square roots of 3 over 3. You need to make another adjustment up there?
No, I had basically the first and the third problem. I had it backwards.
Oh, okay. So how do I get that? Well, 1 over the square root of 3 over 2 is 2 over the square root of 3.
No, never mind. I had it right. It's just that on the board you wrote cosecant and secant backwards what it is.
Oh, I did?
Yes, I'm right.
My fault.
I think I'm right. Nope, still wrong.
All right. Cosecant is 1 over sine. 1 over sine is 2. Let's pause here for station identification. You're listening to Westwood 1's coverage of the NCAA Final Four. Any questions? If you've never listened to sports on radio, you'll understand the pause here for station identification. All right. But all of these problems in this form are based on your ability to work through this chart. Now again, some people will choose just to memorize all the values for sine 5 pi over 6 too. Like they just memorize, oh, sine 5 pi over 6 is 1/2. Cosine is negative square root of 3 over 2. And if you want to memorize it, then so be it. I wouldn't, but if you want to, you can. And if you do, it probably would help you, actually. So while it's a lot of work short term, long term, it probably actually helps you a little bit. Because you don't have to deal with the whole quadrant thing. You just memorize all the damn numbers. That's useful. You just skip the quadrants altogether. So theta negative 3 pi over 4. Where is negative 3 pi over 4? Now, again, I'm going to erase this. For those of you watching at home going, no, don't erase that. Just rewind it. So you just got to tell people, you know, because they're like, oh my gosh, he erased it. It's gone. Pause. Negative 3 pi over 4 takes me to here. What's the reference angle? Pi over 4. So when I go back, now I'm in this column, right? Watch this. Only skilled mathematicians can pull this off. We're in this column, right? If I'm in quadrant 3, sine is what? Cosine. Tangent. Cotangent. Secant. Cosecant. And so on tests when I would take them and I had to do this, that's one of the first things I would do is I'd just go through and label all the signs. Because as a student, I was horrible with negative signs. I'd get the right answer, and then I'd get my test paper back, I have an 80. And I'm like, what the hell? I knew how to do all of these. Oh, that's 5 points for the negative sign there. 5 points for the negative sign over there. Oh, I put negative, it's supposed to be positive. That's another 5 points. And I'm thinking, dang, I just gave away a lot of points. So you might want to think about doing that yourself. So pi over 4, everything is square root of 2 over 2. So this is square root 2 over 2. Square root 2 over 2. Tangent is sine over cosine, so that's just 1. Cotangent is cosine over sine, that's just 1. So secant, which is 1 over square root of 2 over 2, is 2 over the square root of 2. And if you rationalize that, what you ultimately get is square root of 2. Multiplying top and bottom by the square root of 2, you would get 2 square roots of 2 over 2, and then those would cancel. So for these are both square root of 2. Okay. Now, 120. 120. 120 is in degrees. Let's back up. A 120 degrees, which quadrant? What's the reference angle? Who?
60.
It's 60 degrees, right? Which we know 60 degrees is pi over 3. Okay. So, go back. Well, let's fix the signs. Y value, positive or negative? X value? Tangent? Cotangent? Secant? Cosecant? Okay. So let's fix the signs. Now let's go do pi over 3. Where's pi over 3? It's at the end. So cosine is 1/2. This is square root of 3 over 2. This is square root of 3. This is square root of 3 over 3. This is 2. And this is 2 square roots of 3 over 3. All right, any questions on those three? Feel free to ask. I'll even give you a fake name when it's completely made up when I talk to you. Yes, Johnson.
Can you do cosecant with that? Real quick, for fractions?
You mean for that, for just that number 7 or for all of them?
No, the one you just did.
Yeah. So the question is, can I show how cosecant comes out to be 2 square roots of 3 over 3? And the answer is, well, I hope so. So cosecant is 1 over sine, right? So we're looking at 1 over square root of 3 over 2, yeah? Right. Which is the same thing as 2 over the square root of 3 if I just multiply by the reciprocal, right? Square root to the bottom does, we got to rationalize. Square root of 3, square root of 3. 2 square root of 3 over 3. Any questions on that? All right, let's look at number 4. Where we got to solve cosine squared theta is equal to 1/2. We're trying to figure out what theta is. Now, notice I said for all theta. I did not say theta is an element from 0 to 2 pi, which means you just got to deal with one time around the circle. I'm saying you got to deal with all of them. Now, if I take the square root of both sides, I get cosine theta equals plus or minus the square root of 2 over 2. Do we agree? So I'm asking, in essence, what x coordinate has a value of either square root of 2 over 2 or negative square root of 2 over 2? So what x value has that? Well, the x values are positive in which quadrants? 1 and 4. Do we agree? So 1 and 4 is when the x values are positive. So what's that angle when you get square root of 2 over 2? Pi over 4. And what's this one going to be? Negative pi over 4 would do it. What is it in the positive angle, though? 7 pi over 4. So for the square root of 2 over 2, we have two answers. Pi over 4, 7 pi over 4. Do we agree? Now, where is it negative at? Quadrants 2 and 3, right? So we're negative then here and here. Well, that makes this pi over 4 and makes this pi over 4. So what are those two answers? Who is it? What did you say? 3 pi over 4 and 5 pi over 4. So those are the four answers that are from 0 to 2 pi. Do we agree? But do we further agree that not only is pi over 4 an answer, not only is pi over 4 an answer, but if we go around the circle one whole time, that's 2 pi plus pi over 4 would be another answer. Right? I mean, there are a lot of possible answers here. and you must give them all. So when you give them all, generally what you do is you put the number plus some function of k pi, meaning I got to go around the circle some number of times. How long does it take before you find another answer? From here to here, how long does it take before you get another answer? What's that total distance across? Pi over 2. From here to here, how far is it? Pi over 2. From here to here, how far is it? Pi over 2. From here to here, it is pi over 2. Do we agree? So we come to an answer every pi over 2 units. Okay, so what I would say is the answer for this problem is pi over 4 plus k pi over 2. Now, why do I say k pi? K represents all the time that you can go around and around and around and around and around. Okay. Any questions?
So that would be the answer, how you write it out.
Right. It's okay to ask. Like, let's be honest. There's 2, 4, 6, 8, 10, 12, 14, 16, 18, 22. There's about 22 people in here. Right now, 19 people are going like this. What the hell did he just do? I'll watch it at home. It'll make it so much better. Ask. Go.
Is that a plus sign
Where?
between the pi over 4 and k pi? Is that k pi over 4?
This?
Yes.
No, that's k pi over 2.
Wait, why?
And this is the plus sign. Why is that k pi over 2?
Yes.
To get from one answer to the other answer, it's not pi over 4. It's pi over 2. Okay? So it's just how far do you have to go before you run into another answer. Now, let's simplify this for a second. Or make it way more confusing than it needs to be. I don't know what we're going to do with it. Let's say I give you cosine theta equals square root of 2 over 2. It's not just positive. It's just positive, not negative. What would the answers be? Well, we know that pi over 4 is an answer. And we know that 7 pi over 4 is an answer. Yes? That's what we just talked about. Huh? No, it's a 4. See? These are the y's. That's a 4. No, this is a y. This is a 4. And would you please keep them straight? Don't note so hard about that.
Looks like a y. Thank you.
7 pi over 4. Perfect. Any other discussions? Here's the point. Now I'm erasing the origin. If this is pi over 4, and this is pi over 4, this distance is pi over 2, yes? And again, some people are going like this, well, how in the hell do you know that? If it's pi over 4 and pi over 4, if you got 2 quarters, you got a half. Just go to McDonald's, it'll work itself out. However, this distance is a half a pi. This distance here is not half a pi. Do we all see that? So it's not a uniform distance from one answer to the next. And so in that case, we would just do 2k pi here, and we would just do 2k pi here. Meaning, answer, go back around 2 times, and you'll get another one. Go back around again, you'll get another one. Go back around again, you'll get another one. And people go, well, negative. All right, go the other way. So this one, because there's not a uniform distance, both of them are just set plus 2k pi. This one had a uniform distance from one value to the next, and that distance didn't change for each answer. And that's why we only have to do it with one solution. That was supposed to be the moment where you all go, oh. Much better. All right, moving on. So, but that's kind of how that works. Now, what if I said to you, tangent theta equals 1? And maybe this will be the final draw that helps you see it. When is tangent equal to 1? Pi over 4, right? But this is positive 1. Go ahead, ask. How does she know that? It's okay. When is tangent, which is sine over cosine? When is it 1? It's 1 when these two are equal to each other, yes? Which is at pi over 4. All right? So if I ask you, when is tangent equal to square root of 3? Then you go to the thing and you find out when is sine over cosine equal to the square root of 3. You'd say pi over 3. Does that make sense? So when's tangent theta equal to 1? If this is pi over 4, or what? This is pi over 4, yes?
Wait, how would you know that though?
Okay, so tangent theta is positive. So in order for the tangent to be positive, it's either got to both be positive or they both got to be negative.
Okay.
Right? Because if it's here, one's positive and one's negative. When you divide them, you get a negative number.
Okay, I kind of understand.
Okay? So remember, sine's positive here. Cosine's positive here. Everything's positive there. Over here, the only thing that's positive is sine. Sine's positive here, but cosine's negative. Tangent is positive here. And cosine is the only thing positive here. Hence the acronym, all students take classes. Everything is positive, only sine, only tangent, only cosine. All students take classes. Okay. That helps you to remember the signs on the values, that's fine. If not, use the x and y's. Now, with that being said, tangents equal to positive 1 in quadrant 3 and quadrant 1. So the jump between this one to this one is how far? How far do you got to go to get from here to here? Pi. How far do you got to go to get from here to here? So it's uniform on both sides. Do we agree? So what do I say? The answer is pi over 4. Because you got to start at pi over 4, and then you jump by k pi. Now, there's always somebody who goes like this. Dryer, just shut up. Can I write pi over 4 plus 2k pi, and then 5 pi over 4 plus 2k pi? I want to do it that way. Like, just keep going around in circles, and you go around in circles, and we'll just do it that way. That's not simplified. This is the simplified final answer. Yes, please.
What does the K mean?
It's a great question. What does the K mean? A really good teacher would have told you that ahead of time. My fault. K is an integer. So it just means 1 pi, 2 pi, 3 pi, 4 pi, negative 1 pi, negative 2 pi, negative 3 pi. So all the possible answers for this will fall in that formula. Does that make sense? So K is just an arbitrary integer. Yes?
Is pi over 4 always going to be an answer?
No. Only if it's square root of 2 over 2 it would be. But if this were like, say for example, tangent theta equal to the square root of 3, then you'd have to go get the square root of 3 one. Okay. Any questions on that?
So when a question asks us for all the values of
Then
theta,
if it asks you for all the values of theta, then you got to use some function of pi. If it says 0 to 2 pi, then you would be able to go that route. Going once, going twice.